My dear students, myself Sanjay Kumar Behra, lecturer in Zoology, Nalanda, Vidya, Mandir. Today's topic is sex-linked inheritance. First of all, you know about the inheritance. What is inheritance? Inheritance means transmission of characters from generation to generation. Transmission of characters from one generation to next or other generation is said to be inheritance. The next, what is sex linked? That means linked with sex chromosome. Inheritance, transmission of characters from one generation to other generation. Next, sex linked, that means linked with sex chromosome. So what is sex linked inheritance? Transmission of characters from one generation to other generation linked with sex chromosome. Each sex linked inheritance. Now, what is this character? You know, there are two different types of chromosome, autosome and sex chromosome. Autosome responsible for somatic or body character, and sex chromosome responsible for the sex character. Autosome responsible for transmission of somatic character, and sex chromosomes responsible for the transmission of sex character. Sometimes the sex chromosome may transmit the somatic character. Sometimes the sex chromosome may transmit specific type of somatic characters. And this transmission of autosomal character, transmission of autosomal character, transmission of autosomal character linked with the sex chromosome from generation to one generation to other generation is sex-linked inheritance. Such autosomal characters which are transmitted through the sex chromosome, such autosomal characters which are transmitted through the sex chromosome is said to be sex-linked character. The autosomal characters which are transmitted from generation to generation linked with sex chromosome is said to be sex-linked character, and such genes are said to be sex-linked genes. What is such genes? That means genes for autosomal character. Genes for autosomal character or the sex-linked character. Such genes, that means genes for the specific autosomal character or the sex-linked character, are said to be sex-linked gene. The sex-linked gene again of two different types. One is X-linked and other one is Y-linked. The sex-linked genes are of two different types, X-linked and Y-linked. The Y-linked gene also said to be Hollandric gene. Y-linked genes also said to be Hollandric gene. Why? Because found in male only. Such genes are found or restricted to Y chromosome only. Y-linked genes found on Y chromosome only, and this Y chromosome is found in male only. So Hollandric genes restricted to Y chromosome and so found in male individual only. And Y-linked character is hypertrichosis. Hypertrichosis or hairy ear pinna. Hairy ear pinna. The ear pinna with the hairs. Ear pinna with the hairs. Hairy ear pinna is the character of only male individual, never found in the female. Sex-linked genes are of two different types, X-linked and Y-linked. Y-linked also said to be Hollandric gene, which is found in Y chromosome and restricted to male individual only. Example, hypertrichosis. And such genes are transmitted from father to son only. Father to son only. Next, X-linked. The X-linked genes found in both male and female. In case of human, female is homogametic and X as it produces similar type of egg with X chromosome, and Male is heterogametic as it produces two different type of sperm, some with X chromosome, some with Y chromosome. And as usually, when the sperm with X chromosome fertilize the egg, the young one becomes female, and when the sperm having Y chromosome fused with egg having X chromosome, the young one becomes the male. So if the female is mother and male is father, then here is daughter and son. Mother with two X, whereas father with only one X. Mother transmit its X chromosome, mother transmit its X chromosome to both son and daughter. Mother transmit its X chromosome to both son and daughter. But father transmit its X chromosome only to daughter. Again, I repeat it. Mother is homogametic, produces similar type of egg, and mother transmits the X chromosome to both son and daughter. But the single X chromosome of father always transmitted to daughter only, whereas Y transmitted to son only. So, a daughter receives its X chromosome from mother and from father. A daughter receives its X chromosome from both father and mother, whereas a son receives its X from mother and Y from father. That's why the Y-linked genes always transmitted from father to son. Y-linked Y chromosome never transmit to daughter. The Y-linked character always transmitted to son only. It's the son received the Y chromosome from father and X chromosome from mother. Whereas daughter received the X chromosome from mother, another X from father. The X-linked genes in case of human being, mostly recessive, and example, hemophilia. And color blind. Hemophilia and color blind. Both of the diseases controlled by the specific recessive gene. H, the sex-linked gene are the recessive genes. So, the recessive gene only expresses its character in homozygous condition, that is double dose. The female without recessive gene, the female without recessive gene is normal female. The female without recessive gene is normal female. The female with one recessive gene, is carrier for the disease. Carrier for the disease. It may said to be normal, but carrier. And this condition is heterozygous. But if the female is with two recessive gene, that is, if both the alleles are recessive for a character, then the female is affected female. Here, the affected female with the disease, and this is homozygous. So female normal if without recessive gene, female carrier if with one recessive gene, female affected with disease if with two recessive gene. One recessive gene, heterozygous condition. Two recessive gene, homozygous condition. Just like that, the male, if the male is without the recessive gene, the male without recessive gene on X chromosome, it is normal male. But if X is with the recessive gene, if the X chromosome with recessive gene, then male is affected. When the male is affected, if the X is with the recessive gene, then the male is affected male. And remember, male never becomes carrier. Male never becomes carrier because here single dose is expressive, and this condition is said to be hemizygous. Single dose recessive gene is expressive, so the condition is said to be hemizygous. This is about the introduction for sex-linked inheritance. Again, I repeat all the things. Mother transmits its X chromosome to both son and daughter. Father transmits X chromosome to daughter and Y chromosome to son. Daughter receives one X from father and one X from mother. A son receives X from mother and Y from father. Here, the female without recessive gene, normal. With one recessive gene, carrier. Both the recessive gene affected with the disease, homozygous condition. In male, without recessive gene, normal. With X chromosome with recessive gene, the male is affected and the condition is a hemizygous condition. If the sex-linked gene is found in mother, the sex-linked gene from mother transmitted to both daughter and son. Just like that, the sex-linked gene from father only transmitted to the daughter, not to the son. So, a daughter may become affected. A daughter may be affected if the sex-linked genes on both mother and father. Whereas the affected son receives its character only from mother. Then the sex-linked inheritance, the example, hemophilia. What is hemophilia? Hemophilia, also said to be the royal disease or the breeder's disease. Hemophilia, also said to be a royal disease. Why it is so said to be royal disease? H. It was found in the royal family. Found in the royal family of Europe, starting from Queen Victoria of England. Hemophilia, also said to be royal disease. AIDS. First of all, this disease found in the royal family Europe, starting from Queen Victoria of England. Then, this disease also said to be bleeders disease. Why so said to be bleeders disease? Because the blood failed to clot. Why so said to be bleeders disease? Because blood failed to clot. The normal clotting time is 7 to 8 minutes. The normal clotting time is near about 7 to 8 minutes. But in this disease, the blood failed to clot for a long time, and which may causes the death of the patient. And why the blood failed to clot? Because of the absence of blood clotting factor. Because of the absence of blood clotting factor, 8th and 9th. The absence of blood clotting factor 8th may identify age, type A, hemophilia, and absence of blood clotting factor 9th may identify as type B, hemophilia. This is more common, and near about 20% individual may suffer from type B hemophilia, and it is also said to be Christmas disease. Absence of blood clotting factor may causes hemophilia. Next, this hemophilia controlled by a recessive gene, by a recessive gene, and the gene is anti-hemophilic globulin, may represented by small h. The presence of recessive gene in single dose in female, the female becomes carrier if the recessive gene found in double dose, then the female is affected, but in male, the single dose is expressive and it is affected male. Affected, that means hemophilic. This disorder, the hemophilia, first of all studied by John Otto. First of all studied by John Otto. So, the carrier female is with one recessive gene, affected female with two recessive genes. Here it is heterozygous, homozygous, and hemizygous. Female carrier in heterozygous condition, female hemophilic or affected in double dose homozygous condition, the male affected or hemophilic only in single dose, that is hemizygous condition. This hemophilia, how it transmitted from generation to generation. Let one example, one of the example. When a carrier woman marries a normal man. When a carrier woman, that is heterozygous, when a carrier woman marry a normal man, mother, father, the mother produces two different type of egg, one with normal gene and other with hemophilic gene. As it is homozygote, gametes are with X chromosome, but why different? Basing on the presence or absence of sex-linked gene. One without a sex-linked gene, one with the sex-linked gene. Father produces sperm with X chromosome, and sperm with Y chromosome. When the normal X chromosome containing sperm fertilized the normal X containing egg, the daughter becomes normal. No sex-linked genes found. No sex-linked genes found, so normal. And when the egg with normal X chromosome fertilized the sperm having Y chromosome, here the son is normal. Then when the egg with sex-linked gene fertilized the X containing sperm of father, then the daughter becomes carrier. The daughter receive normal X chromosome from father. Daughter received the normal X chromosome from father, but hemophilic gene from mother. So the heterozygous condition means carrier. The heterozygous condition, daughter becomes carrier. When the egg containing sex-linked gene fused with the Y chromosome, the son is affected. The son is hemophilic. The son becomes hemophilic. If the son receive the sex-linked gene from mother. Here, the conclusion is heterozygous mother has 50% son normal and 50% son hemophilic. If mother is carrier, then 50% son normal, 50% son hemophilic. There is the chance. And if father normal father have no affected daughter, because the affected daughter should have double dose, but father is normal, so normal father have no affected daughter. So when a carrier woman marries a normal man, then 50% son normal, 50% son hemophilic, 50% daughter normal, and 50% daughter carrier. Then another example. If a example, when a hemophilic man marries a normal woman, So woman normal, that is X and X, male hemophilic, that means X hemophilic Y, X hemophilic Y. X hemophilic, X Y, X hemophilic, X Y. Here both the son normal and all daughters carrier. When a hemophilic man marries a normal woman, when a hemophilic man marries a normal woman, then all son becomes normal. Why? All son becomes normal. Why? Age, mother, normal. Normal mother had no affected son. Just like that, as mother is normal and father hemophilic, the daughters carrier, because daughters receive the sex linked gene only from father. So they becomes carrier as they have normal mothers. This is all about the sex linked inheritance with the example hemophilia. That's all. I will discuss in the next class about the color blind. Thank you.